This is section 1.5. We are solving inequalities. Section 1.5, we're solving inequalities. We definitely did this in Algebra 1 or Algebra B, whatever class you had. We're going to do a couple of different things. We are going to look at verbal phrases and change that into algebra. We're going to solve some inequalities, and we're also going to look at some word problems where we'll have to write an inequality and solve it to answer the question. A couple of key phrases that you might want to be familiar with. If you see the phrase less than, this is kind of not true. If you see the phrase less than, that's the symbol we're talking about. If you see the phrase at most, that's the symbol we're talking about. Less than and at most. At most is less than or equal to. Less than is simply less than. Greater than, I'm talking about that symbol there. At least is that symbol. So we're going to start by looking at some verbal sentences and some words, and we're going to change that into an inequality. The first one says the product of 7 and a number is greater than 42. The product of 7 and a number is greater than 42. When you see the word product, what does that make you think? Multiplication. So I'm going to start with the multiplication sign. The product of what? 7 and a number. Those are the two things that we're multiplying. 7 and a number. Is greater than. Is greater than. Greater than, I guess, could mean addition, but in this situation, it is talking about an inequality. Greater than 42. We'll talk about solving here in just a bit, although you guys should be able to solve that without trouble. 7n is greater than 42. How about this one? The difference of twice a number and 3 is at most 11. The difference of twice a number and 3 is at most 11. When I use the phrase the difference of, what operation am I indicating? Subtraction. So I'm going to start with the subtraction symbol. And I'm trying to figure out what two things I'm subtracting, and it'll tell me. It says twice a number. What does twice a number look like? 2x or 2n, whatever variable you want to use. Twice some number, we'll use x. And that's indicating the other thing we're subtracting, which is 3. The difference of doesn't mean I have to change the order. What were the two phrases where we need to change the order with subtraction? Less than and subtracted from. Less than or subtracted from. That doesn't apply here, so let's keep moving. It says is at most 11. What symbol did we write down means at most? Less than or equal to. Less than or equal to 11. So when we go about solving these inequalities, it's really similar to solving an equation, isn't it? There was a couple of things that we had to remember. If we multiply or divide by a negative number, what do we have to do? If we multiply or divide by a negative number, what do we have to do that's special? Switch the sign. We need to switch our inequality symbol. So if you multiply or divide by a negative number, switch the inequality symbol. If you multiply or divide by a negative number, switch the inequality symbol. So we're going to look at a few inequalities where we're going to solve them, and then we're going to practice graphing them on a number line. Here's our first one. It says 4y minus 3 is less than 5y plus 2. Graph the solution set on number line. Alright, so we're treating this like an equation. We know we have to get the like terms together. We know if we multiply or divide by a negative number, we do have to do something special. But what would you guys do first? What do you think we can do? Savannah.
We should get our variable on the same side.
Okay, what would you like to do?
Subtract 5y.
That'll work. Let's subtract 5y from both sides of the inequality. That will combine some like terms. 4y minus 5y is negative y, minus 3 is less than 2. Keep going. We want to get the y by itself, so we know that we would add 3 to both sides of the inequality. So we have negative y, or the opposite of y, is less than 5. What could I do to get rid of that negative on the y? Divide by negative 1 or multiply by a negative 1. It doesn't matter which one you do. Now, we are dividing by, dividing by a negative number, so what did we say we had to do to that symbol? We have to flip it. So the solution is y is greater than negative 5. When they say solution set, that's what they mean. Okay? That is read y such that y is greater than negative 5. Okay? That's the fancy math language for the answer. I'm okay with y is greater than negative 5. But when they refer to solution set, that's what they're meaning. It does tell us to graph the solution set on a number line. So could you draw a number line and plot these solutions? I hope so. Will we use an open or a closed circle at negative 5? Open. If you don't remember that from Algebra 1, if it's less than or greater than, we will use an open circle. If we have less than or equal to, or greater than or equal to, our number line will have a closed circle. In Algebra 1, we learned that if the variable is on the left side of the inequality, it's really easy to graph, isn't it? We just make this inequality symbol into an arrow. My arrow is pointing to the right, so when I draw my line, it's going to go to the right also. So we solved, we got our solution, and then we graphed our solution on a number line. Let's try another one. Q minus 2, parentheses, 2 minus q, close parentheses, is less than or equal to 0. Do you agree that we should distribute first? Let's start with that. I'm going to distribute the negative 2. So negative 2 times 2 is negative 4. Negative 2 times negative q is a positive 2q, is less than or equal to 0. Let's combine like terms. Q plus 2q is how many total q's? 3 q's. They're on the same side, so just add them as they appear. Q plus 2q is 3q. Minus 4 is less than or equal to 0. We should be able to solve this. Go ahead and add 4 to the other side. So we have 3q is less than or equal to 4. Of course, divide by 3. So q is less than or equal to 4/3. And it's okay to have a fraction. I wouldn't want to make this into a decimal because I would have to round. 4/3 is a repeating decimal, and we don't want to round an answer when we're trying to get an exact answer here. So leave it as 4/3 if you would. Let's graph this. Four-thirds is really like 1 and 1/3, right? So it's between 1 and 2 on a number line, the closer to 1. So 1 and 1/3 is approximately there. We would use a closed circle, of course, because the symbol is less than or equal to. What direction is the graph going to go? To the left. I know it's going to go to the left because that's the direction my inequality symbol is pointing. So we have solved the inequality right here, and we graphed our solution on the number line. Let's try another. Not this one. 4x minus 3, all divided by 2, is greater than or equal to negative 3.5. If we want to solve this inequality, what should we do first? Multiply by 2. So I'm going to take the left side and multiply by 2 and do the same thing to the right side. Is this a situation where we will need to flip the inequality symbol? No. Just go ahead and multiply. Cancel out those 2's. I have 4x minus 3 on the left is greater than or equal to negative 3.5 times 2 is negative 7. Go ahead and solve. I'm going to add 3 to both sides. So I have 4x is greater than or equal to negative 4. Divide by 4. X is greater than or equal to negative 1. I'm going to set up my number line to graph my solution. When you do your number lines, I really haven't said much about those, but put several numbers on there if you would, please. Don't just put negative 1. Put a couple numbers, maybe before or after, just more than just negative 1 if you would, please. Should we use an open or a closed circle there at negative 1? A closed circle, and we know that because it's equal to. And what direction is our graph going to go? To the right. something like this. 12 is greater than or equal to negative 0.3p. Do you agree that if we want to get p by itself, we're going to divide by negative 0.3? So I'm going to go ahead and do that to both sides of the inequality. Now there's going to be a lot happening in this next step. Yes, we're eventually going to need to move p over to the other side, right? But let's leave it on the right side because in this step, aren't we also going to flip the inequality symbol? Okay, we've got too much going on. So one thing at a time. 12 divided by negative 0.3 is what? Negative 48. I divided by a negative number, so we know that does what to my inequality symbol? It's going to switch it. And I'm going to leave p over here on the right side. The reason I didn't go ahead and flip p to the left side is because, did I make a mistake?
Negative 40. That's what I had, Scott.
What is it?
Negative 40.
Negative 40. That's my fault. I just heard you wrong. Sorry. The reason I didn't go ahead and flip p at the same time that I wrote this answer is because when I flip p to the other side, what's going to happen to that symbol? It's going to flip again, isn't it? I don't want to make any silly mistakes, so I'm doing one thing at a time. So go ahead and move it down. When I divided by a negative number, that caused me to flip it the first time. When I moved p to the other side, I flipped it yet again. So real quick, we can graph this on a number line. At negative 40, on my number line, will that be an open or a closed circle? It will be a closed circle. In what direction is my graph going to go to show all the numbers greater than or equal to negative 40? To the right. I'm looking at this symbol here. Pointing to the right, that's the direction my graph is going to go. How about this one? The opposite of x is greater than x minus 7, all divided by 2. What would you do to solve this inequality? Yeah, multiply both sides of the inequalities by 2. So 2 times negative x is negative 2x. Do I need to flip the inequality symbol here? No. The value we multiplied by was a positive number, so still greater than. I'm left with x minus 7. What would you do next? Subtract x. So negative 2x minus x is negative 3x. Is greater than negative 7. The next step, we should divide by a negative 3. Do we need to flip the inequality symbol here? Yes. Negative 7 divided by negative 3 is a positive 7/3. So it should be x is less than 7/3. So 7/3 would be like 2 1/3. 2 1/3. So 2 1/3 would be approximately there. Of course, the graph is going to the right. The next thing I would like to do is look at those 2 word problems on the handout that I passed out at the beginning of the hour. So let's go there next. Consumer costs. Javier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $1.59. If gasoline at this store costs $2.89 per gallon, how many gallons of gasoline, to the nearest tenth of a gallon, can Javier buy for his car? When we have a word problem like this, I think it's very important that you understand the question. What are they asking of us to find? How many gallons of gas, to the nearest tenth of a gallon, can Javier buy? Okay? That's the unknown. That's what we need to let X be, or whatever variable you choose to use. I'm going to use X. X is going to be identified as what we are trying to find. We're trying to find the number of gallons of gas. So X, number of gallons of gas. It's very important that you define your variable. Start with that every time. X is the number of gallons of gas here. The very first sentence says Javier has at most $15. How would you write at most $15? What does at most make you think? Less than or equal to $15. Okay? So I'm going to start with that. I'm going to build on this. So whatever Javier is going to spend is going to be right here. It has to be at most $15. We know that he buys a bag of pretzels and a bottle of juice for $1.59. He only did that one time, correct? If gasoline at this store costs $2.89 per gallon, how many gallons of gasoline can Javier buy for his car? Well, we're going to add to that the potential gas. We know that it's going to cost $2.89 per gallon. How can I show $2.89 per gallon? $2.89 X is correct. So the $1.59 was how much he spent on the pretzels and juice. Plus he's going to get some gas. It's going to cost $2.89 per gallon. That has to be at most $15. Make sure after you've written your inequality that it makes sense. I think this does. Let's go ahead and solve this. You should get a long decimal. Did you get something like this? I made a mistake. Do you agree with this? Okay, now they specifically told us where to round, so please be aware of that. Nearest 10. So 6 is my 10th digit. I'm looking at the 4. Is the 4 going to round a 6 up or leave it at 6? Leave it at 6. So I want you to make sure you round correctly. It's going to be X is less than or equal to 4.6. 4.6 gallons. Does he have enough money to purchase 5 gallons of gas? No. It says the number of gallons of gas, which is X, has to be less than or equal to 4.6. Does he have enough money to purchase 3 gallons of gas? Yes. The number of gallons of gas has to be less than or equal to 4.6, and 3 is less than. Could he purchase 4 gallons of gas? Could he purchase 4.5 gallons of gas? Yes, as long as that is less than or equal to 4.6, we're good. All right, so I do want to make sure we answer this with a sentence It said how many gallons of gas can he buy? Javier can buy at most 4.6 gallons of gas. We always want to wrap up a word problem with this sentence summarizing our findings. Javier can buy at most 4.6 gallons of gas. Let's try one more. Rental cost. Jeff wants to rent a car for his vacation. Value Cars rents cars for $25 per day plus 25 cents per mile. How far can he drive for one day if he wants to spend no more than $200 on car rental? What are we trying to find? How far you can drive. How far? What are we measuring it? Number of miles. So let's let X, or whatever variable you want to use, represent the number of miles. So I have written X is equal to the number of miles that Jeb can drive. Something that jumped out at me is it said no more than $200. When it says no more than, what do you think that means? Less than or equal to. When I hear no more than, I think not more than. Well, the opposite of not more than is less than or equal to. So less than or equal to $200. I'm going to start with that and I'm going to build off of this. Once again, this is kind of a slope-intercept form type of situation. It says he's going to pay $25 per day. Well, how many days is Jeff planning to rent this car? Just one. So he's only going to pay it one time. Plus, he has to pay for each mile that he travels. So how am I going to show 25 cents per mile? 0.25x. 25 cents times the number of miles that Jeb can drive. Let's go ahead and solve this. Subtract 25 from both sides. Divide. $175 divided by 0.25. Did you get 700? So which one of these answer choices is going to be correct? Well, B and D can be eliminated off the bat, right? Can he travel more than 700 miles? No, it says less than or equal to. I think you're right, letter A. Up to 700 miles. Doesn't have to go exactly 700, but he could go 700. So let's write a sentence. We'll say that Jeb could travel at most 700 miles. Jeb could travel at most 700 miles. are solving inequalities today. We kind of grouped everything with inequalities here together because it is a review. You guys did pretty good with this back at number 1. Today's homework is partially out of the book and partially on a handout. Let me go ahead and pass out the handout. The assignment is typed on the top of this. There are 3 word problems here that I want you guys to try. Now, not every word problem is exactly the same, and there's no way that I could ever tell you. We'd be here all day if I told you every way that you could write an inequality for every word problem, you know what I mean? So use your reasoning skills, use your thinking skills, and we can come up with inequalities for each of these. Again, there is a book assignment here on the top. It says page 37. Numbers 10 to 20 evens, and 24 and 26. And I also want you to do these 3 word problems. If you want to put the bookwork on the back, that's fine. If you want to put it on a separate sheet of paper, that's okay. Just, if you put it on another sheet of paper, staple it to this handout. Okay, when we turn it in, we'll staple it.